Welcome to Lesson 2 of Module 3 on the Relational Data Model. I'm going to start with two practical questions that motivate integrity rules for relational databases. I want you to think about these questions as you engage with this lesson. What is the consequence of two taxpayers or customers with the same government identifier or customer identifier? What is the consequence of a shipment associated with the wrong order? Lesson 2 continues your learning about the relational data model with a focus on integrity rules that ensure an essential level of validity for rows stored in tables. After this lesson, you'll be a step closer to using commercial relational DBMS for practice problems and graded problems. The objectives of this lesson involve a deeper understanding of key components of relational database. First, you should be able to identify one-to-many relationships and associated primary keys and foreign keys in a relational database diagram. Second, continuing your usage of sample tables from Lesson 1, you should be able to identify rows with either missing foreign key values or orphan foreign key values. Third, in the database diagram for the university database, you should be able to identify foreign keys that are required, that is, must not have a missing value, and foreign keys that allow missing values. Before providing two integrity rules for relational databases, I will start with important definitions of null values, primary keys, and foreign keys. The integrity rules on the next slide use these terms. A null value indicates a missing value in a row. A null value means that the actual value is unknown or not applicable for a row. A primary key is a column or combination of columns with unique values. Unique means that no two rows of a table have the same value. In the university database example from Lesson 1, student number, STD in the student table is unique, and the combination of student number and offer number is unique in the enrollment table. If a primary key contains more than one column, no column can be removed and still retain uniqueness of values. Single column primary keys, the typical situation, are always minimal. A foreign key is a column or combination of columns related to a primary key in another table. A foreign key has the same data type and often the same name as the related primary key. For example, student number in the enrollment table has the same name and data type as its associated primary key, student number, in the student table. Now I want to provide some informal but useful definitions for the two major integrity rules for relational databases. I will depict these definitions with examples in the remaining parts of this lesson. Entity integrity means that each table must have a primary key. A primary key cannot have null values in any row. Entity integrity ensures that entities, people, things, places, and events, are uniquely identified in a database. For auditing, security, and communication reasons, business entities should be easily traceable and unique. Referential integrity means that column values in one table must match column values in a related table. For example, the value of student number in each row of the enrollment table must match the value of student number in some row of the student table. Some foreign keys can allow null values, although most foreign keys do not allow null values. Referential integrity ensures that a database contains valid connections. For example, each row of the enrollment table contains a student number of a valid student. Otherwise, some enrollments can be meaningless, possibly resulting in students denied enrollment because non-existing students took their places. To test your understanding of integrity rules, let's look at these sample tables from the university database. Note that student number is the primary key of the student table, offer number is the primary key of the offering table, and the combination of student number offer number is the primary key of the enrollment table. In addition, student number is a foreign key in the enrollment table, referring to student number in the student table. Offer number is a foreign key in the enrollment table, referring to offer number in the offering table. In these sample tables, missing values are shown by hyphens. For example, the fourth row of the student table has a null or missing value. The sixth row of the enrollment table has a null value for student number. Please take your time to identify integrity rule violations in the sample tables. You should be able to find 2 violations of the entity integrity rule and 1 violation of the referential integrity rule. A database diagram is an important tool for understanding relationships and identifying integrity rules. This Oracle database diagram shows the tables and relationships of the university database. In previous examples, you have seen the student, offering, and enrollment tables. This diagram adds 2 new tables, course and faculty, denoting courses in the university catalog and faculty who teach at the university. To help you understand this diagram, I will talk about the meaning of the notation. The primary key of a table is marked with a P. For example, course number is the primary key of the course table. Foreign keys are marked with the F abbreviation. For example, the offering table has 2 foreign keys, course number referencing the course table and fact number referencing the faculty table. The lines represent relationships with referential integrity constraints. Each relationship is a parent table appearing next to the arrow in the line and a child table appearing next to the foot symbol. For example, the line between course and offering means that a relationship exists from course to offering, with course as the parent table and offering as the child table. This relationship means that a course can be related to many offerings. A solid line means that the foreign key cannot have missing values. For example, the values in course number column of the offering table cannot have missing or null values because the relationship line is solid. A dashed line means that the foreign key can accept missing or null values. For example, the fact number foreign key in the offering table can accept null values as the faculty for an offering may not be assigned until after the offering is initially entered in the database. The PF abbreviation indicates that a column is both part of the primary key and a foreign key. For example, offer number and student number in the enrollment table are both components of the primary key. In addition, they are foreign keys to the offering and student tables, respectively. You will see the database diagram for the university database in most lessons in Modules 3, 4, and 5. A database diagram is essential for understanding the major components, primary keys, foreign keys, and relationships of a database, and formulating queries that combine tables. As you will see in Modules 4 and 5, most tables are combined using a relationship with a primary key from a parent table, matching to a foreign key in a child table. For example, you will typically combine the course and offering tables on course number in the course table, matching course number in the offering table. Let's wrap up this lesson giving details about 2 essential integrity rules for relational databases. To understand a relational database, you need to identify primary keys and foreign keys. Primary keys must have unique values for each row. No part of a primary key can have a missing or null value. Foreign keys must have a value matching a primary key in a parent table. Some foreign keys can allow null values, such as an offering not yet having assigned faculty. A database diagram provides a convenient representation highlighting primary keys, foreign keys, and relationships from parent tables to related child tables. As you will see in Modules 4 and 5, understanding relationships is crucial for query formulation. Now let's return to the initial questions at the beginning of the lesson, with 2 new questions added pertaining to details covered in this lesson. What is the consequence of 2 taxpayers or customers with the same government identifier or customer identifier? What integrity rule is violated? What is the consequence of a shipment associated with the wrong order? What integrity rule is violated?